Hello everyone. Today we'd like to discuss the next theorem here is maximum power transfer theorem. Yeah, this one is a continuation part for the part of Thevenin's equivalent circuit. We all know this Thevenin's theorem. Equivalent circuit here is series circuit. VTH in series with RTH to the part of RL. This arrow mark indicates change in that load resistance. Okay, now what's that? IL is the value. Current flowing across this particular circuit here is IL is equal to V divided by RTH plus RL. This one is the formula. We all know that per formula P equal to I square R. And I know the value of I now. Substitute this I here. We get the value of power. V square RL divided by RTH plus RL whole square. Remember one thing. In some of the textbooks they have given V Thevenin or source voltage is also the same. Thevenin's resistance or the source resistance is also the same. Yeah. Don't bother about that thing. Yeah. I conclude that one thing here is that load power is equal to some formula. But our intention here is in order to find out condition for the transfer of maximum power, we all learned in plus 2 that in order to find out maxima and minima values, we remember differentiate that thing and equate it to 0. We get the values of maximum and minimum values. Same thing I would like to apply here. I would like to differentiate this power with respect to changing quantity here as load resistance and equate it to 0. That's the only parameter. D by D or L. This one entire thing is nothing but power. And I would like to use this VTH square is constant, bring before the part. And I would like to apply differentiation for this one. This resembles things of U by V formula. U by V. V constant, differentiation of U minus U into V dash divided by V square. That's the only thing I apply here. This entire source voltage doesn't becomes 0. And this entire part will equate to the part of 0. And obviously, I may get some value of RTH plus RL whole square is equal to that part. This RTH plus RL one times cancelled there. We get the value of one thing. That one is nothing but load resistance is equal to Thevenin's resistance. Yeah, load resistance is equal to Thevenin's resistance. At that time only, we would like to transfer power from source to load. Our theorem indicates the part here is maximum power transfer theorem. Now, how much amount of power will transfer from source to load? That's the only intention. It can occur only one condition there. That condition is nothing but load resistance is equal to Thevenin's resistance. Substitute this value in this equation. That it is RL is equal to RTH now. 2 times of RTH whole square. That it is 4 RTH. One time cancelled here. We may get some value of P maximum is equal to VTH square divided by 4 RTH is the maximum power in this particular one. This one is the final formula you have to remember. Yeah, only one simple procedure. By knowing Thevenin's equivalent circuit, from that I would like to have some load current here. From that I know the power formula I square R. What's the thing? Substitute in this one. In order to find out the condition here for the part of transfer of maximum power, differentiate that thing with respect to RL and equate it to 0. And utilize this formula, we may get some value here as load resistance is equal to Thevenin's resistance. And we get substitute here, we may have the value of maximum power V square by 4 RTH is the value. Yeah, remember this one is also written as load resistance is equal to Thevenin's or else source resistance. That's the only condition. Yeah, I'd like to go for the part of statement. The statement for the maximum power transfer theorem. Nothing new. We all know one sequence now. In any linear active bilateral network, the maximum power will transfer from source to load if what's the condition? Load resistance is equal to Thevenin's resistance or source resistance. This one is only. Just remember, in any linear active bilateral network, the maximum power will transfer from source to load if and only if the condition load resistance is equal to Thevenin's resistance or else source resistance. This one is the statement. Yeah. One more conclusion point here is what's efficiency of maximum power transfer theorem is the condition. Yeah. We all know that efficiency indicated with this letter, the output power divided by input power. We all know that output power, we derive that part now, maximum power, that it is V square by 4 RTH. What's the input power is equal to, we all know, V into I. But I know that I formula here is this one, V into V divided by RTH plus RL, that it is nothing but 2 times of RTH. This one is nothing but input power and this one is nothing but output power. Substitute in this equation. Output V square by 4R, V square by 4R divided by V square by 2R. This V square cancel out. We may get some value of how much, this 2R, and that one is nothing but approximately 0.5. In terms of percentages, this one is 50%. Remember, efficiency of maximum power transfer theorem here is 50%. That's the final conclusion point you have to observe. Yeah, thank you.